So the first lecture I talked about the basic terminology. I hope that you still remember what do we count accident. Say involving a vehicle, involving injury or damage, and also accident cost, we have some way to calculate it. This willingness to pay is something that is very interesting. If you are interested, you could try explore it. We call it as the equivalent life. So one life that is lost in accident, how much is the value about it? We did a review in many different countries. We find very interesting about that figure, actually quite interesting. In Eastern country, this value is lower, but in Europe, US, this value is very high. That is why I say one human life is equivalent to 9 million US dollar, quite high. So, this part I will talk about what we say traffic calming. This traffic calming is measures that we try to tackle the road safety problem, or we want to try to improve the road in the local area. So what does it mean by a local area? Maybe it is an area that is designated for residential, or there could be an area that have many schools, many children walking around. Then they would do this traffic calming. Quite often we see this in US, Australia already have this traffic calming. So I would first talk about it. Before we talk about this traffic calming, there are some basic definitions things would be that road hierarchy. There are many different road types. We classify them into 4 or 5 classifications. Depends on the lead of the country. Some countries, they classify the road into 5 different classes. Some classify them into 3 to 4. So what does it mean by road hierarchy? For example, on a motorway, what is the speed limit? Usually 80 or even 100. Do Korea have 100? Yes. So in urban road, what is the speed limit? 50. And then some area we have 30 kilometers. Why do we set different speed limit? Why we have 80, 50, 30? Have you think about it? Why do we have this? Or in your mind, if you imagine a motorway that have 80 or 100 kilometers and an urban street that have 50 or 30 kilometers, in your mind, could you tell me what are the difference between them? If you imagine. Can you tell me some difference? What are the difference? If you see a picture, you know that this is a motorway for 100. It is a street for 50. Why can't you recognize it? What are the difference between them? Geometric. Built environment. How about the road sign? The sign of the street. Is it different? Motorway, there is a barrier. Can you stop your car, park your car? No, isn't it? On the street, you can park your car, you can stop, you can get off. So you could imagine they serve different functions, isn't it? So when we talk about this road hierarchy, first we need to understand about the functions of them, isn't it? Motorway, 100 kilometers, we are not expecting the car to stop or to park, isn't it? For a urban street, we set 30 kilometers because we expect the car can stop, park on the roadway, and then you can drop off. And we also expect we need to let the pedestrian to cross the road. That's why we need to set a lower speed limit. So I will first talk about the road hierarchy, and then what kind of road will be suitable for the traffic calming. This is something that I would like to talk about in this lecture. So traffic calming, the basic definition will be that we use some physical features to say intervene the traffic flow. What does it mean by intervene the traffic flow? That is, making them to change the speed. For example, this road. We make it to be level, isn't it? If you are a driver, you drive along this road, could you drive very fast? Of course you cannot, isn't it? Because I intentionally make it level. And even maybe you can see here, I make a pump here. So can you drive fast? Certainly no, because boom, boom, isn't it? So traffic calming, we say that we use some physical device rather than, of course, we can change the built environment. When we say built environment, maybe you put more tree to make it look like an urban street, more pedestrians would walk around. But more importantly is this physical device that stopping the car, making the car to reduce the speed. This is the basic idea about the traffic calming. And our objective would be that we want to make the road to be safer, especially to the pedestrian. Even in some other European countries, nowadays they encourage the cycling. So we want to make the pedestrian, cyclists to be safer. This is the basic idea about the traffic calming. So first I talk about the road hierarchy. We know that there are two types of the road. Motorway, very high speed, low stopping, low parking. Urban street, we expect the people would walk around. They may get off from a car. They may cross the street. That is why we need to make them to be slower, the speed. So it's related to the history of the development. Say, imagine 200 years ago, do we have car? So basically, people rely on walking. Maybe you are rich. We have many animals in our family. Then we can use the horse, you can use the cow to pull the trolley, isn't it? So this is the way. Do we count them? We have transportation. We have transportation already, even 1,000 years ago, but just depend on human effort, or maybe we are rich, we have the animal to pull the trolley, but we already have the transportation. At that time, do we need motorway? Not really, isn't it? If you walk, you just at any place you can stop, you sit down, you take a rest, isn't it? It doesn't matter. Do the road need to be wide or not? No, isn't it? As long as maybe the trolley they can move smoothly is already enough. This is the first day at the old day that we have transportation. We rely on these two modes. We do not need to classify whether it's motorway or urban street, isn't it? Then later on, the people try to move to some urban center, or not urban, we could not say urban, of course, town center. They try to gather in the town center because of what? They need to do the trading, isn't it? In the past, maybe all the people, they live in the village. We need to build some wall to connect different villages only. Then later on, the people start to do the trading in some town center, isn't it? More shop, or even some people, they move to the town center. Like the people, they do the trade, they will move to the town center, isn't it? Then what happened? This two wall that is in yellow color, it could be connecting the town center and different villages, isn't it? So more people may be using this wall that is of the yellow color, isn't it? So what do we need to do? Maybe we need to make this wall to be wider, to provide for more people come, maybe more trolley. So basically at that time, we start to consider that we may need to make some wall to be wider, to provide some function because of high demand. But how about later on, say in recent 100 years? So people start to move to the urban area. This is the situation in some town, in the town center area. Red, yellow, and green color indicate the traffic demand. So The red one may be very congested. That is the situations that we quite often encounter nowadays, isn't it? This could be a major road that are connecting to different towns, but also passing through the town center. This is quite often the case in many cities, isn't it? What do we have usually in the town center? Could you suggest? Usually having the market. So nowadays there could be many commercial activity, many shops, many restaurants, isn't it? So if there is shop, there is restaurant, what would you expect? Do you allow the car to stop or park here? You should allow, isn't it? Because the people need to go to the shop or the truck need to deliver the good, isn't it? So this road in the city center, town center, you should allow for the people to park the car, or at least for several minutes they can drop off the either passenger or the good, isn't it? But what else? I also say that this road may be connected to other town. Then there could be many traffic that pass by. What would be the issue here? Many congestion, isn't it? And if you are the driver, you only just pass by this town, would you feel happy or not? You may not feel happy, isn't it? Maybe this is town B. This is a road that is connecting town A, B, and C. So there could be many traffic that pass by this. They don't need to stop in town B, but there are also some traffic that they need to deliver the goods, pick up the people, stop here. So this road actually serves this purpose, two purposes, isn't it? People need to park here, drop off it. We call this kind of activities or function as accessibility. Accessibility, that the people need to stop the car here, either dropping off the people or dropping off the goods. Then another group of the traveler, say they travel from town A to town C, they only pass by here. So this road serves the purpose for this kind of driver. They serve the purpose of mobility. So you imagine accessibility, the first group of the people, and the second group of people, mobility. Are they looking for the same thing? Certainly no, isn't it? If you are second group of driver, mobility, you look for what? First but you look for speed, isn't it? So a motorway that has 100 kilometers would help you, isn't it? If you are the first group of driver, accessibility, what kind of thing would help you? Some parking bay would help you. Or if you are someone that want to go to do the trade in the town center, then this road, if it could allow you to cross the street, you would be happier, isn't it? Then this situation, what kind of road would make you happy? 30-kilometer road, urban street would help you. So, this road serving two purposes, is it possible? Can you do two tasks at the same time? Certainly no. So this road cannot serve mobility and accessibility at the same time, isn't it? That is why we need to set the road hierarchy. From those roads that serve the mobility, 100%, these are the motorway. Low stopping, we make the road geometry to be wider. Pavement conditions should be the perfect one, that the road, the truck, all kind of vehicle can pass by very fast. And in the road hierarchy, the lowest one would be something that we allow the people to cross the street safer, not much traffic would be better, more parking space, especially if you are elderly, disabled. So these accessibilities would be the roads that are in the lowest in hierarchy, they serve the purpose of accessibilities. So you imagine 100%, some road would serve 100% mobility, 0% accessibility. Some other road, they serve 100% accessibility, 0% mobility. This would be the most ideal scenario. If in our system, we only have these two kinds of the road, it would be perfect, isn't it? But in reality, what do we see? This kind of road, 50% accessibility, 50% mobility. It may not be that good, isn't it? That is why we need to have the role hierarchy. So now here I summarize what I say. From the story, we know that two purposes we need to serve for our role system. One is accessibility, and another role is mobility. Accessibility, we need to give the people some parking slot to drop down the goods or passenger. They need to cross the street, so we need to make the car to be slower, more crossing facility. Another type of the road, we want to make it to be wider, not much intersection would be the best. So that is why we see that on the motorway, sometimes we use the flyover rather than using the signal. So this will be those the roads that are in the highest hierarchy, even low signal intersection, because we don't want to disrupt the traffic at all. They can move as quickly as possible. This is the hierarchy. So quite often there is conflicts in between, like this one. I grabbed this picture from some Southeast Asia country. Quite often we see this. This will be the situation that you still remember, the road in the town center, the red one. We want to serve this. On the road side, two sides, there are many trailer, hawker on the roads. But it's also a main road. So can we serve two purposes? Certainly no. Even we cannot do two tasks at the same time. Listen to my lecture and then working on the exam, isn't it? So, role hierarchy. We want to make it clear that why we need to have the hierarchy would be that those in the top one would be those carrying the most mobility, and those in the bottom would be carrying the most for the accessibility. So, I take this as say we classify the road into 4 different types. Those in the top, we call them motorway. Some countries, we call them freeway. Usually, maybe 180 km per hour. We have the shoulder provide for some car that break down, not allow them to do the parking, low signal intersection even. So those at the lower one may be principal road or what we call arterial road. Traffic flow very high, but maybe we allow for some signal intersection. Speed limit may be 70, 50, something like that. And then those at the lower one will be collector and local street. Just now I mentioned we put the traffic calming. What do you think? Would we put the traffic calming at motorway, principal road, collector road, or local street? Where would we put the traffic calming? Do you still remember the first slide I say traffic calming? We do some physical measures to make the car to slow down. What do you think? Would we put it at motorway or local street? Should be putting it at local street because the local streets are serving 100% what? Accessibility, isn't it? Local street, we serve the accessibility. We want to lower the traffic, make them slower speed, make them to be easier for pedestrians because they need to cross the road. So traffic calming will be suitable for the one that is in the lowest hierarchy. So motorway usually look like this. This one from Auckland in New Zealand because I have been living in New Zealand for a few years. So you see here, we put a very wide shoulder here, good geometry. We put some sign for say you are going to different district, go different area. They must have very clear sign and very high speed, usually 80 or even above. Arterial road, you see here, a bit leveler, maybe there are some footpath nearby. Also, there could be intersection in between. This is the common. Those in the second level in the hierarchy. And then it's come, the lowest one, I say the local street you see here. We allow for the vehicle to park because there are many shops. Even maybe we provide more for the pedestrian to cross. Sometimes very common in Europe or in Australia, we make the road surface to be in different colors so that making the driver to aware that, hey, now you come to a business shopping area, you need to slow down. Many people would cross the street. So this is the features about that. As I mentioned, two purpose, mobility, accessibilities. The most ideal scenario would be that some motorway only serve 100% mobility. Local street serve 100% accessibility. Of course, this is the perfect scenario, ideal one. But quite often we see that roads are something in between. Quite often, the situation would be like this. This is the perfect, ideal situation. Most of the road, arterial road, principal distributor, we make them to serve 100% mobility. Local street, we make them to do this. But the actual situation usually would be like this. Most of the road would be there is a mix of accessibilities and mobility. This is what the situation that why we have many traffic congestions and also traffic accidents. Basically, it's because of this road hierarchy. We don't have very good idea, or because of the poor design management, there is a mix of these two conflicting functions. This is actually the root cause of why we have congestions and the safety issues. If we can make this, actually we could solve quite a lot congestion problem and the safety issues already. Especially safety for the pedestrian can be solved. So we come back to this. Do you have any idea how can we improve this town? If you are, say, the mayor of this town, what would we could do? Can we take away the shop in the city center? No, usually in the town center, the price would be very high. It's difficult for us to take them away. So what we do usually would be that, how about we make the traffic to divert outside the skirt of the city. So this is why many cities, they make some ring road at the outskirts of the city. Basically, it's this idea. City center, we leave the room for pedestrians. So nowadays, quite often we see this. City center, usually it is the commercial center. We convert them into some pedestrian mall. This is the usual case. And at the outskirts, we build some circular road. So if you are traveling from town B to town C, you just pass by this. What do? Usually, we may be taking this route. This is a better way to manage the network design and also the urban planning. This is the basic idea about this road hierarchy. It is related to the urban planning or city planning. What are the features? So, usually the motorway, we use it to solve the problem about, say, if more than two motorways, they intersect, we try to use this. The purpose is that we don't want to disrupt the traffic. If we put the roundabout signal intersection, we may interrupt the traffic. So, motorway, quite often we see this higher speed limit, not allow the pedestrian to go in, not allow the parking. Local street, maybe it's about 30 kilometers, the speed limit. Sometimes we could also see such a sign, or in some school area, we don't allow the truck to go into it. So this is the sign that quite often we see. If it is a local street, we often see this. If This is a major wall motorway. We often see this. What we want to achieve will be improve the efficiency of the wall for this car, for those on the right hand side. What all this will be that we want to try to improve the efficiency, increasing the speed. Those on the left hand side, this kind of the sign, we want to try to reduce the speed. We want to provide more room for the pedestrian. This is the basic idea about this. So it comes to an idea that we call it self-explaining wall. That is why in the beginning I asked you, in your mind could you imagine what it looked like for a motorway and an urban street? Basically, it's because of this concept. Again, it's about perception. Self-explaining wall is something that is about the perception. When you are a driver, you enter such an environment, you already know this is an urban local street. Because now you see this, many trees, the walls are not that wide, parking is allowed, even you see some sign that warn you that there may be some children walking around. This is a concept that we call self-explanatory wall. That is, when you enter the local area, you know that you need to lower down your speed. Not because of the physical feature, but because of what you see in your eyes. This is what we mean by the self-explaining wall. So this is an example here. We see that this is an example in Australia, New Zealand area that quite often in the residential area, we make it like this. Many trees, many green area. We try to make the traffic lane to be leveler. So it doesn't matter. We put the green tree in between. You say, hey, you make the road to be even leveler, but I say their purpose, isn't it? We want to slow down the traffic. This is the purpose that comes from the self-explaining wall. When you enter this, we don't want the driver to be traveling fast, especially if it is difficult for you to see somewhere ahead, then maybe you will slow down. It's something related to the perception, isn't it? I cannot see what is in front. Hey, I slow down and try to be aware of the surrounding. This is the purpose of this kind of wall design. So we actually did some study to measure the speed. Say for example, this kind of the wall, before we do this kind of the modification, before that maybe the wall are very wide, we didn't provide for the bicycle. We measure the speed of the traffic that pass by. And after we make such a modification and then we measure the speed again, then we could see that from this diagram, the one in the lower part. So this distribution is what we do the speed measurement before we do any modification. We find the distribution of the speed, the vehicle traveling at around 50. And then some road we do the treatment, say put some tree, making the road to be leveler. The driver really, they drive slower. The speed average, on average, is reduced to 30, really. This is the one on top is something, some town or some city that without such a treatment, we see that the vehicle, they actually travel quite fast. And what more will be that you see here, the distributions for this is it leveler. If you look at the diagram on top, what would you see? The distribution is wider. So, Professor Zhang tell me that you learned this statistic, isn't it? So what does it mean for this leveler? Wider, actually, what makes this wider, those on top is wider, the distribution. What value is greater? You learn statistics, isn't it? What makes the distribution to be wider?
I didn't teach.
You didn't teach? Oh, okay.
Like other professors.
you still remember standard deviation? Isn't it? Anyone still remember what is standard deviation? Or do you know how to calculate mean? Mean you should know how to calculate mean. If you have 10 numbers, you add them and then divide by 10, you calculate the mean. Isn't it? Standard deviation, anyone know what does it mean by standard deviation? Each value you subtract the mean, isn't it? And then you take the square, divide by n minus 1 square root is the standard deviation, isn't it? What does it mean by standard deviation? Hey, come on. Maybe look at this. This distribution, I say level. What does it mean? Maybe on, I take this diagram as an example. On average, the speed is 50. But of course, each individual driver are different. Maybe it's like Cole. So it's more careful, he drives slower. I'm more aggressive, I drive faster, isn't it? So some driver may drive 55, 60, isn't it? So this is the standard deviations that matter. This wall may be the minimum speed. Those lowest drivers, they drive at 40. Those most aggressive drivers, they drive at 60. So the range of the speed of the car is from 40 to 60, isn't it? The range will be about 20 only. But if you look at the diagram on top, say I take this line, maybe those drivers who drive the lowest, he drive as 20 only. But some driver, they drive at 80. So even though the mean also 50, but you see here, some driver, they drive at 20, some at 80, isn't it? The range is greater or smaller compared to the case lower one. It's much, much greater. So not only the mean, is the range of the distribution of the speed that matter. So imagine if you are a pedestrian, you want to cross this road, some traffic come very slow, 20, but some people come very fast, drive at 80. Would it be issue? It could be an issue, isn't it? Some people drive very fast and it's difficult for you to judge. But for this road, the driver, more or less they drive at the same speed. It's easier for you to predict how fast the vehicle comes, isn't it? So this traffic calming issue will be that not only reducing the mean speed, but we also see that the distributions or the range of the speed is also not that big. This distribution of the speed, we find that is also something that affects the safety quite a lot. So we bear in mind, mean speed, it affects safety, but the range, usually we use the standard deviation of the speed to determine this, also affect the safety very much. If the range is smaller, it will be better. So this traffic calming actually serves two purposes when we are talking about we modify the distribution of the speed, not only the mean, but also the standard deviation. We try to make the standard deviation to be small also. This is something that I will come back later on again. So, traffic calming is something related to the physical features. Nowadays, we do quite a lot in what we call smart mobility, isn't it? Marcus also talked about this. We call this intelligent transport system or smart mobility. Nowadays, quite a lot. Say, for example, even if you are driving a car, inside our car, there are many different kinds of the information system. The map navigation is already one kind of the application, but you may not know. Say, for example, ITS or intelligent transport actually help us quite a lot in managing the public transport. Say, for example, this example would be that in some urban area, that if we use this technology to detect the bus that are approaching and give priority to this. This is a measure that can also help improve the efficiency of the public transport. Why I mentioned about this is something also related to the safety also. So I would like to show you a video about that, say how we apply some what we can say technology in managing the vehicle safety. Actually, it tries to resolve the problem about human perception or human error also.
Thank you.
So how many kind of technology did you observe here? Can you name some in this video? Some advanced technology in this bus system. Did you observe? Did the driver touch on to the steering wheel? A kind of autonomous. Did you realize that when it passed through the intersection? Did you see that? When the bus passed through the intersection, the signal detected the bus also. One more thing, quite already implemented many years in many different cities, that the predictions of the arrival time of the buses, isn't it? Or we could also provide the information on the apps on the mobile phone, even nowadays. So this is some way that nowadays we apply this technology to improve the efficiency of the public transport also. So I just want to in between to give you something about that rather than keep hearing listening what I say. So anyway, come back to this. I used 5 minutes to try to finish this. So we understand that role hierarchy, we classify them into 4 or 5 different types of the role. Basically, it's because they serve 2 different purposes. We try to distinguish these 2 purposes, isn't it? For local street, we know that we want to serve the purpose of accessibility. And one message that we try to emphasize these accessibilities would be this, using this traffic calming. Traffic calming, we say that we want to reduce the speed, isn't it? Not only the mean, but also we want to reduce the standard deviation. So go back to search what does it mean by standard deviation and tell me later on. So come back to this traffic calming. Several objectives. We don't want to make too many vehicles to pass by because these are the roads that serve the accessibilities. No need to pass by if you are not going into this area, isn't it? So we want to reduce the traffic volume. More importantly, we want to reduce the traffic speed. Sometimes we also want to reduce the noise. That is why I say quite often you put in the school area, hospital or residential area. We see one of the examples here that say we intentionally trigger this, isn't it? Originally, the road was very straight. Why do we do this? We force the driver to slow down if he need to do something like this. So this is one of the way how we do the traffic calming. And as I say, we want to reinforce this hierarchy to try to distinguish motorway is serve mobility. Local street is serve the accessibility. This is something that we want to achieve, and it is related to what I say road hierarchy. There are 5 different types of the treatment. Vertical deflection. What does it mean by vertical deflection? Is that we create some road pump. So if you drive through, boom, boom, boom. So you will slow down, isn't it? Horizontal deflection, very simple. Just like what I saw this picture here. The driver lead to this maneuver around. So this is the horizontal treatment. Surface treatment. What does it mean by surface treatment? We change the color of the road. Say originally, usually it will be in black color, gray color. We use the red color to indicate. Now you enter a area that have pedestrian. This is what I mean by surface treatment. Sight distance. We put some tree nearby so you could not see what is around the corner. Then the driver will slow down. This is what we mean by sight distance. Road closure. Later on, I will show you some examples. So, these examples are horizontal deflections. Quite common in UK here. Originally, this is a road for two-way traffic. At some point, we make this so only one direction vehicle could come. So, you need to slow down and need to check whether there is a car that are oncoming. This is another type of the horizontal treatment. Traffic calming, there are several issues that we need to resolve. For example, we need to say avoid isolating the speed treatment. What does it mean by not isolating this? For example, how often do you need to put this? Say, for example, if along the street you only make 1 or 2 only, what would the driver do? Just like you see the speed camera. After you pass by, you then speed up again. So we need to be careful about how frequent we put this. This is what I mean by avoiding isolated. So these are some issues about it. For example, hey, how about making it more frequent? But maybe bombs, then you would not speed up. So this is what I mean by avoiding isolating them. Traffic calming could also be integrated with the level. So we need to plan ahead where we put the locations of different kinds of the traffic calming, and it is related to the level. What does it mean by the road level? So the last 5 minutes, we talk about road hierarchy. There are 4 different types of the road. They serve 2 purposes. But how they are arranged is the issues about the level topology. What does it mean by level topology? I show you this figure, maybe you could realize. Could you see difference between these 2 pictures? Very different, isn't it? But what is the difference? What is the shape of the road for the one on the left-hand side? Straight, and then this one not very straight, isn't it? So, this is the way that in 100 or 150 years ago, when we design a town, usually we would design the street like this. Say in America, like San Francisco, in the city center, we see the street look like this. We call this a grid system that all the roads are rectangular. there are two, say for every wall segment, there are two exits. This kind of the wall network, we call them arterial. Arterial, that every single street only one exit. Only one exit. So here, what I want to show here would be that there are two types of the network type. This is the one that I say originally how we design the wall network of a town. We call this grid system. For the grid system, there are many different routes. For example, if I want to go from point A to say point B, there are many combinations, isn't it? You may go straight here and then go down this, but you could also try traveling this, isn't it? Is it good for enforcing the wall hierarchy? It may not be quite good, even though we may know that these walls that are more thick, we may think that it is the motorway or major wall. But the vehicle that travel from A to B, they can select to travel by the main mode, but also can consider traveling through the local street. So this kind of the wall network may not be quite good if we say that we want to distinguish between mobility and accessibility, because especially in what situation do you think the driver will try to go in this area? Hey, how about during the peak hour? Will you try to go to the street that at the inner? But usually, this inner area is what? They are residential area. So what I want to mention here that this kind of the network, grid network may not be quite good in terms of traffic calming and in terms of we want to make it to be clear for different kind of the wall type. This one may be better. This kind of the wall network, those in between, those here, they only have one exit. So if you are traveling from A to B, you only have one choice. You need to use the main wall. You would not go into the residential area. So these two types of the network here, I just want to emphasize, it can actually reinforce the wall hierarchy, and it would also be easier if we want to implement the traffic calming, because the people have no choice. Unless you go into this area, you would use this kind of the wall, and we make more traffic calming, no people would actually complain about it. For this, many people, they try to take the shortcut. Is it easy for us to put the traffic calming? It may not be easy. So this, I just want to illustrate the relationship between these two types of the network and the issues about how we implement the traffic calming and reinforcing the wall hierarchy. Some other way to reduce the speed, I don't want to go through in detail, but I just want to illustrate here. There are two types of the wall network. Grid type may not be quite suitable if we want to emphasize the wall hierarchy. So this is what I want to cover in this part. Any questions?
Previously, people designed roadway with the grid system if they want to increase the car moving capacity for the same land space, isn't it?
Yes, yeah. But you could see also not very efficient, isn't it? If in the old day, this yellow and the white color area also occupy quite a lot of the urban space, isn't it? This would also, this may be better in terms of the utilizations of the whole urban space also, yeah. That is why I said this grid was told in the old day how we design a town. Any other?
I just wanted to know if you do some kind of simulation to analyze the capacity or safety
Yes, quite often this would be, if we want to evaluate, we can do the simulation with different type of the volt level. Yeah.
You also consider the trade-off between a stable state.
Yeah, we can. Then it comes to the issues about how we value safety and efficiency, isn't it?